Hello and welcome to another live virtual office hour. Bonus for those of you attending for the live radar and satellite tour that will come shortly to showcase all of the sort of weird and unusual and interesting weather that's going on across a lot of California right now, and that's been going on in recent days in association with the heat wave and now probably more notably the major monsoonal moisture surge that has unfolded across most of California and also into the Pacific Northwest, as well as the Great Basin and interior West. Apologies if you hear some crows in the background. They apparently decided to come very close to the window here right for this session. Just a moment here, double checking that everything is as it should be. All right, well, so today I want to focus primarily on that monsoonal surge, the large number of lightning-ignited wildfires that have been sparked so far, not just in California, but also into the Pacific Northwest and across the West, and a number of points of discussion related to lightning-ignited fires and the spectrum from benefits that those lightning-ignited fires will pose in some spots to the potential harms to come later on. And we are just in the beginning of what looks like a pretty big lightning-ignited wildfire outbreak along the Pacific Coast states. And we are heading into a period that appears to be relatively dry and also warmer than average across most of this region once storms today clear out. So there is significant potential for a lot of the fires that are currently burning to escalate, or for what are known as holdovers, those smoldering trees or other vegetation that was hit by lightning, but it rained and so it didn't immediately erupt into flames, but there's still some low-intensity combustion going on, waiting for an opportunity to pop up. We've been seeing a lot of those holdover fires in recent days, and I actually expect to see a lot more of them tomorrow when things dry out and the sun comes out. Talk all about that and more, as well as what might be on the horizon the next couple of weeks. Also talk a little bit about the slight potential for some tropical storm remnant moisture to affect far southern California, probably just San Diego County and maybe not even that. Doesn't looking like a significant event right now, but we'll talk about it since it's interesting. It's out there. People have been discussing it. I also had a brief piece of new information I just wanted to reflect on when it comes to the rehirings of the double or triple fired roles at the National Weather Service, and some of the stipulations that are apparently coming attached. Some pretty substantial strings, it seems, from reporting today. So not a comprehensive federal update, but just wanted to touch on that one point since we've been talking about the cuts to NOAA and the Weather Service so prominently in recent months. But today's focus will mainly be the short-term weather and wildfire conditions, and that'll probably take up the bulk of the hour. Once again, and I didn't mention it last time, so I wanted to make sure I did today, that this channel is partially sponsored by Reask, a climate tech company that's helping companies rethink their extreme weather risk and exposure in a warming world. Okay, so I have a lot of visuals that I would like to show today, so I think I'm just going to jump right into that and start actually with radar imagery. Now, what I'm going to show is not the current radar. I've queued up, gone a little bit back in time and queued up the radar from this morning and early afternoon in the Central Valley. So we're going to be looking at the Sacramento radar from earlier today in just a moment once I pull that up. Okay, so now you're going to see this Sacramento radar from earlier in the day. Now keep in mind, normally the radar view I'm showing you includes lightning. I think for the historical data, the archived lightning data is not available, so you won't see it. But this is from earlier this morning, and this is local time, or I believe it may be shifted by 1 hour with my current time zone relative to Pacific time. But in any case, it was this morning Pacific time. And there's a few interesting things that I wanted to talk about in this loop. More than a few, but I'll focus on a couple of them. One is notice this very unusual trajectory of these radar echoes from northeast to southwest, or kind of north to south perhaps, across the northern and central Sacramento Valley. These were high base showers and, yes, thunderstorms. There were some places, especially in the orange and reds, that got some lightning, including lightning that sparked a couple of wildfires up in this region and also up in this region. None of them are really big right now, but they did spark some fires because they did produce cloud-to-ground lightning strikes without a lot of precipitation. There were some very brief downpours, but you can see the amount of precipitation associated with all of this activity was very isolated and relatively brief, and it kind of fell apart. So you got some gusty winds. Again, this is not current. This is from this morning. But there were thunderstorms that made it all the way into the Central Valley, including down into the northern Sacramento suburbs. So Roseville probably heard some thunder this morning, maybe even had a brief shower. And there was also lightning up in eastern Lake County, Colusa counties, and up along the eastern slopes of the Coast Ranges, as well as the western slopes of the Sierra Nevada. Last night, which is not showing on this radar loop, there were thunderstorms into the northern Sacramento Valley near Redding, Red Bluff, etc. Also earlier this morning, some fairly intense thunderstorms in the northern and central San Joaquin Valley. So from about Fresno up through Merced, again producing some showers and some lightning, which did again ignite a couple of new fires this morning on the southern Sierra foothills. So there was progression of these storms into the Central Valley. That's less common, of course, during monsoonal patterns than it is in the mountains. And the other unusual thing is, even though the moisture source for this came up from the southeast, from the monsoon, the actual trajectory of the individual storms was from north to south. And this because of essentially a sort of weird mesoscale low pressure system that was sort of spinning like this. Even though at higher levels of the atmosphere there's a high pressure system spinning in the opposite direction, what we actually had was at lower levels a low pressure system, and that made all the difference. The low pressure system was probably the catalyst for giving the upward vertical development needed for these showers to produce lightning, and also for them to move in this kind of weird trajectory. And you can kind of see the showers down in the San Joaquin Valley were a little more quasi-stationary. But I'm going to now bring up the live radar. So this is no longer going back in time, and what you see is that the showers in the valley have essentially ended. We don't have any more activity. In fact, most of the clouds have cleared. But there is still some interesting sort of trajectory of storms. So you see this line of pretty intense heavy thunderstorms in northeastern California, north and east of Quincy and Sierraville and Chester, kind of moving to the southeast. So still some weird trajectory there. And then this cluster of storms over the central and southern Sierra moving eastward. So we still have that residual effect of that cyclonic spin in the atmosphere. We also have a pretty big cluster of storms over the Coast Ranges and the northern mountains of California. I'll go to a different radar site to showcase that better. But we are seeing, and I wanted to point this out, there are some isolated storms. They're not over the valley, but they are over the Coast Ranges. In fact, the most recent shower is developing near northern Lake County. But I wanted to show a couple of things associated with this. One is, well, let me step through this. Let me get to the right. Yes, so this is sort of what I wanted to show. This is not a particularly consequential shower. This is from a couple hours ago. But I wanted to show you something. So consider this area here. And this is a map which is going to show the lightning. So as I step through time, you see that this isolated shower is the definition of an isolated shower. There's nothing in any other direction. It's clear skies, but there's a nice cumulus cloud with a downpour underneath it. As I step through here, you see that first there's a cloud-to-ground lightning strike, and look where it occurs relative to the precipitation. That's a lightning strike outside of the rain core, and that's what we mean when we say whoops, that's not where I meant to go here. That takes us to Colorado. But this is what I mean by isolated dry lightning strikes. These are not dry thunderstorms. There was, and there has even been, some flash flooding associated with these thunderstorms in recent days. But look what happens with some of these showers when they blow up, and this is earlier in the day. In this case, all of the lightning associated with this thunderstorm fell essentially in a different place than the precipitation was falling. That's why these kinds of isolated bolts from the blue, you could call them, these may even be clear sky lightning bolts near the storm. Well, they're dangerous if you're out and about, but also this is how lightning can strike even from a storm that's producing, if you're in this bubble, a very heavy downpour. And that's sort of what we're seeing all around California in the last couple of days. Storms that are not necessarily purely dry thunderstorms. In fact, there's very heavy rain associated with some of them, but the lightning strikes are frequently occurring outside of the primary storm core region. In fact, take a look at what happens. Here's another example of this. Here's currently, or a little while ago, a heavy cell up west of Shasta Lake, a flash flood warning. So obviously a lot of rain associated with that, and yet this lightning strike falling from that storm producing potentially flash flooding completely outside the storm core. Now in this case, that storm did end up developing further south, so it looks like those initial strike regions did get some rain, which means that particular strike was less likely to start a fire. But now we have new storms and new strikes falling outside of the rain core. So I'm going to go north a little bit to a radar site in the northern San Joaquin Valley, northern Sacramento Valley, Beale Air Force Base. Here's a closer look at those heavy cells west of Redding. This is a fairly long radar loop for a couple of hours. And you can see, again, these storms are pretty wet storms. They're probably even producing some flash flooding, but there are lightning strikes that are starting fires on the storm peripheries. Now, you see all these dazzling lightning strikes over here? This radar might make it look like it's all dry lightning, but that's just because the beam is blocked. What's really going on, if we go to the Reno site, is we see that these are relatively wet thunderstorms. This is the longer loop here. But even here, for example, just north and east of Truckee, lightning occurring outside of the rain core of some of these storms. So if you get lucky, a subsequent storm will come up and dump some water over the previous dry strike regions, but that's not occurring everywhere, and that's why we're seeing quite a few wildfires popping up. If I go to Southern California, well, San Joaquin Valley anyway, the southern Sierra Nevada is kind of quieter today than it has been in recent days, so there's not as much going on there now. But the deserts of southeastern California, let's see if I go to, I think I probably need to go to Yuma, Arizona to get this. You see there's big storms in the Imperial Valley, in the Coachella Valley, some flash flooding north of Borrego Springs, up by Barstow on the highway there, Victorville, some pretty strong storms. There's even a severe thunderstorm warning out over near Ridgecrest, although there's really not much radar coverage up there to speak of, so can't see it. Go to LA. Let's see if we see anything better. Not really, not great coverage here. I'm trying to think if there's a better Southern California radar for this particular part of the state for coverage here. The southeastern deserts, by the way, do not have great radar coverage in this part of the world. It's a known issue. These are more traditional monsoon thunderstorms. You can kind of see that there's flash flood warnings up in Arizona. If you're in slot canyons, and this is a bad day to be in a slot canyon in southern Utah, there's a severe thunderstorm warning near Las Vegas. Phoenix last night was hit by a severe thunderstorm and a massive dust storm known as a haboob that engulfed the city and brought damaging winds, even brought part of the roof off at Phoenix Sky Harbor Airport. The last thing I wanted to show on the radar, going back to Sacramento, is just something that's kind of weirdo, and I'm not even exactly sure what's going on here, but here's my hypothesis. If you look at this region here, right near the intersection of Interstate 5 and 505, just northwest of Woodland, there's some strange things that have been going on the last couple hours. Here, there was the very final decaying elevated shower. You see it up in this region here, just up north of Arbuckle. You can kind of see it in the early frames here, just kind of passing through and then poofing out, going away. I think that decaying shower developed a little bit of an outflow boundary, so a downdraft of wind that kind of moved south in this direction like that as that little isolated shower moved through. Meanwhile, you have a bit of a sea breeze, essentially a delta breeze front coming up from the Carquinez Strait, so sort of slightly cooler marine air coming up like this. And I think what you can see is essentially what's happening is there's this almost convergence boundary. You can actually see it on radar right along here. Look at this complex behavior. It's almost like a mini warm front and cold front kind of situation going on. That's not really what's happening here, but there's boundary convergence. You see it more often on like the Florida Peninsula, summer afternoon, or on the Great Plains during severe storm season. I don't think there's enough surface-based instability because this is a boundary that's colliding right at the intersection of 505 and Interstate 5 to produce any new thunderstorms. But it's just kind of fascinating to see that you can, on radar, quite clearly see the delta breeze, as some of our favorite Weather West commenters in Yolo County have called it, the Melta breeze, the sort of the marine air that arrives at the end of a heat wave, and it's a pretty hot wind initially, so it's a hot breeze, not a particularly refreshing one, but it still sometimes portends an end to the heat, so it's still sometimes welcome. But that Melta breeze, sort of a pun on the delta breeze there, definitely in evidence here, although in this case in northern Yolo County, meeting this outflow boundary from a decaying monsoonal elevated shower. Just one of those fairly innocuous but fascinating things. My prediction is if you're on the interstate right here, what you might see, probably no clouds to speak of, but just a gradient in visibility. So there's probably some dust, some trapped insects, maybe even some birds who are a little bit confused, getting redirected and swirling around in this area right now. That's my guess as to what you would see. And in fact, I can do a little bit better than guess if we zoom in using the satellite. Let's see if there were in fact any major clouds there. And I think I'm right. I'm not really seeing, and I'll bring up my drawing tool just for clarity. This is sort of where that's happening. No clouds to speak of, clear skies, but there is this interesting little boundary here. And you can kind of see elsewhere, there's all these swirls. Here's the big thunderstorms over the Sierra Nevada. If we zoom out a little bit, or a lot, let's zoom out a lot, look at the western U.S., the southwestern U.S., you can see that there was this big push of monsoonal moisture that came into California like this, but now it's starting to move eastward. So the main push of monsoonal moisture was earlier this week with the heat wave. It's now starting to recurve outward, but we still have big-time thunderstorms along the mountains, the peninsular ranges in northern Baja, and the transverse ranges in California, the Sierra Nevada, the northwestern and northern mountains of California. There's active thunderstorms all across the west today in classic summer monsoonal fashion, but they are also extending up into the Pacific Northwest, so we are also seeing storms really into western, even Oregon and central Washington, certainly eastern Oregon, Washington. Could even be some coastal thunderstorms later this week in the Pacific Northwest. That's a slightly different story. But the other piece I wanted to show is the infrared imagery here. And what you can see, is not a whole lot, because a lot of these, what I really wanted to show were the wildfires. But there's so many clouds right now that the wildfires' heat signatures, you can see one up in up in Idaho, up here, really the most prominent one is up in northwestern California, which you can see, although the cirrus anvil from these thunderstorms is popping up, another heat signature there. We'll probably see more if you look at this same infrared imagery tonight. Later tonight, once some of these thunderstorms have died down, you'll see more active fire activity then. But speaking of fire activity, let's just hop right over there. Here's the Watch Duty app once again. I'm going to zoom out because the zoomed out picture is pretty interesting. We've re-entered a very active fire period across a lot of the western U.S. Interestingly, Southern California pretty much avoided major fires during this potential plume-dominated fire event this past weekend, so that's good news. There really weren't any major significant fires. There were certainly some ignited by lightning, but they were all pretty manageable. So what's happening right now is actually the major fire activity in California is up from the northwestern mountains, the northern mountains, and then down the Sierra chain. In particular, the southern Sierra and the northern Sierra. The central Sierra, less fire activity right now, but there have been pretty large lightning-ignited fire outbreaks in the north and the south, as well as northwestern California. But also look at Oregon. You can't even quite see, but there's a lot of new lightning-ignited fires up there. Idaho, western Montana, really active with a ton of big fires up there too. And also Utah, Colorado, the northern Arizona, the Mogollon Rim region, remaining really active for late in the season. So this is a particularly active fire map, and I expect this map will get even more active in the days to come with all the lightning we've seen. As the rain moves on, a lot of these lightning strikes that didn't quite enough to have fires take off yet because they were wet strikes will likely pop up later. So let's do a little bit of a tour of some specific fires of significance. The Little Fire in the southern Sierra, that took off pretty quickly, but was stopped partly in its tracks by a big thunderstorm downpour a couple days ago. So that one had the potential to go very big, but then ended up having the benefit of a major downpour, which really helped on containment. I don't know what the official containment is, 29%, but there's not a lot of heat on this fire, so they may or may not have caught this one. The problem is there's still open line, and as the sun comes back out and as the thunderstorms go away, the uncontained parts of the line could become more active again. So that's why there are actually still some evacuation orders in effect. We'll just see how that goes in the coming days. You can see there's other smaller fires that are throughout the southern Sierra. It remains to be seen if any of these quote-unquote go big. We'll see. One that has already gone big is the Garnet Fire, which has no containment, remains very active, and you can see it blew out yesterday with very strong thunderstorm outflow winds. It's already around 9,000 acres. This is very likely going to be a 10,000 plus acre fire, and depending on how things go in the next 48 hours, this could be filling in a pretty big gap in the Sierra of unburned area. So a lot of the Sierra Nevada has burned in very large, higher intensity fires in the past 10 to 15 years. The Garnet Fire is now burning into an area that hasn't burned in recent history, and that could be a problem, at least in terms of the potential spread. Now, we know that in the natural history of a lot of the Sierra, there is a recent fire deficit, so depending the intensity of that re-entry into recently unburned area that this fire may achieve, the benefits versus the harm will essentially depend on how quickly it moves and the intensity of that fire and whether it goes on to affect communities and infrastructure. This does have some potential to do just that, given that it's in a fairly remote area and it's probably going to be pretty difficult to control it on its northern flank. They may keep it north of, I think it's the Kings River here, yeah. It looks like it is so far. It might well remain north of the Kings River, but I think, as we go north and west, I think it's going to be a lot harder, and I think you see that reflected in the evacuation orders for this fire extend well north up toward Three Sisters. So that's a pretty big evacuation zone. Granted, not a lot of people live there, but it is a major recreational part of the state. We go north. Again, there's that gap where there's not currently a lot of fire activity in the central Sierra. A couple of smaller ones. The Coyote Fire from last week was a really good catch. This one could have been a big problem, and there's also a lot of wildland-urban interface on its flanks, but that was a good catch by Cal Fire, a good example of under moderate fire conditions that air resources can be really effective. Still not convinced that they are under extreme conditions, but fortunately that's not what we had, and the outcome was relatively good accordingly. You can tell that we're starting to get into large-scale lightning fire outbreak territory when they start naming the fires not after a location, as is typically the case, but they're just numerically. So the 6-3 fire, the 1-2 fire, the L3 fire. We start to see that when there's a lot, numerous ignitions all at once in close proximity. So the L2 fire, we see these, the 2-2 fire, the 3-2 fire. You start to run out of the H10 fire, the 322 fire. You start to see these when we start to run out of place names, or there's not an obvious place nearby and there's numerous new ignitions. And we see that a lot during simultaneous ignitions during lightning outbreaks. So this is an indication that we are having a fairly large lightning outbreak, and some of the largest fires that we've seen so far that are burning with some significant intensity. I don't know about this one. This one, it's not huge, but it's definitely still burning. You can see that in the live camera view, and it's burning, it looks like, in heavy timber, so we'll see where that goes. That has some potential. We see that some of these other ones are currently just small little, like for example, this is a single tree on fire, probably lightning struck that individual tree, and there's folks responding. So sometimes these get stopped, like this one, the 2-2 fire. Sounds like forward progress has been stopped. That was a 2-acre fire initially, and it's now being managed. Some of these are more active than others. The vast majority of these individual tree fires from lightning strikes get caught pretty quickly, but some of them don't, and it's not always easy to know in advance which is which. This one, actually, you can see multiple fires in this view, for example. I'll bring this up larger on screen. So you can see active helicopter aircraft activity, but these fires have some wind on it, and you can see there's multiple lightning ignitions, and these look like they have some wind on them, so they're starting to take off. So these ones are not probably going to be contained to a single tree. It looks like they already haven't been. We go a little bit farther north and west. This is where we've had some bigger time lightning ignitions. So the Peak Fire, for example, at last update, this was already a couple hundred acres. You can see from this photo that's pretty steep terrain. Let's see if we can get an image, a live camera view of either of these. That is actually a different one. This is the 6-1 fire. So the camera just turned to this one. This is yet another new lightning ignition up in the Shasta Trinity Forest region here. Not huge, but again, it's starting to show some increased signs of activity. This camera's pointed in a different direction from the same tower, and you see yet another fire up on the slope. So pretty much these are all from lightning strikes. Here's the Peak Fire, and I don't think there's a camera that's currently pointed toward it. This one, the Dillon Fire, had a large pyrocumulonimbus cloud yesterday. This one has some pretty significant evacuation orders associated with it. It's already over 1,000 acres. Looks like it has another pyrocumulonimbus cloud right now. Let's bring that up. Look at the last 15 minutes or so. And I think this is the fire itself. Yes, it is. So yeah, so you can see right here that that's the fire, and it is generating what appears to be a fire thunderstorm cloud, pyrocumulonimbus cloud. Not a particularly extreme one. If we look at the last hour, let's see here. Yeah, so it is, it's been pulsing up. That's a pyrocumulonimbus cloud. You can see that it's, it is a pretty impressive one. Actually, I take that back. So it's pulsing. This is a very active fire. It's generating its own thunderstorm. So this one's likely well above 1,000 acres at this point. And we go north into Oregon. There's some major fires burning. The Emigrant Fire yesterday produced another pyrocumulonimbus cloud, possibly a fire tornado. The Flat Fire is large. This is 25,000 acres, very active, evacuation orders. And there's even some fires. Remember that early August unusual atmospheric river that affected the Pacific Northwest and Washington? Well, believe it or not, the couple inches of rain was not enough to extinguish the Bear Gulch fire, which has actually become more active again with renewed evacuation orders. And so we're definitely still in fire season throughout the West. And I think this monsoonal surge, it's been much deserved, much appreciated to see these thunderstorm downpours. but on balance, it's likely sparked many more fires than it has extinguished. So we're actually entering now September with far more fires in heavier vegetation in timber and more remote regions than we were a few weeks ago. And that's in the context of a period, I'll talk about the forecast in a minute, it looks like it's going to heat up and dry out and maybe get windy. So that's not necessarily the pattern we like to see. This is a pattern where I would expect to see escalating fire activity and behavior in the coming days with numerous additional new ignitions. Now again, not all of these are going to be a problem. In fact, the vast majority of these are going to be small fires that burn a single tree or a few acres and really aren't a big deal, providing more benefit than harm. But a few of them will likely go on to become problematic, at least a few of them, and that's the problem, is we don't know in advance necessarily which is which. One more fire I wanted to mention, the Pickett fire up in Napa County. It's a pretty big one, 6,800 acres. There's still some evacuation orders and warnings in effect, but the good news is this one looks like it's been well managed. It blew out to the north and east, and we had a couple of days where it had pretty major spread, large pyrocumulus, not cumulonimbus, I should say. There were lesser fire plumes here. But fortunately, there's not a lot of heat visible left on this fire, and I think that this footprint may, if we're lucky, end up being pretty close to the final footprint here. So we were lucky this wasn't a fire that developed during a major offshore wind event, or it could have produced big problems for Calistoga and the Highway 29 corridor. But fortunately, it did not. And I think this one is likely, I don't know what the official containment is, so only 17%, but the reality is this one is one of those ones where it's a pretty good-looking 17%, let's put it that way. Different story, though, up in northwestern California with the Dillon fire, and in the Sierra with the Garnet fire in particular, as well as a few other ones that have the potential to get much larger depending on conditions in coming days. And you can see, like, as I've been talking, there have been updates on new fires. You know, the 6-1 fire, the Bear fire. Yeah, that's yet another new fire just 5 minutes ago while I'm talking. So there's going to be more of these to come. Okay. Oh, and just to give a perspective, this is what the Garnet fire looks like right now. Not quite as active as yesterday, though obviously a very active fire on multiple fronts still. And it looks like it's cloudy right now. That might be partly why, but it's starting to stand up, and this one likely has some legs to move further. Okay, so I want to look at the forecast. This is where we are right now. As often, this is the Tropical Tidbits website, and I'm showing you the anomalies, so the departure from average for the time of year of geopotential heights in a standardized way. So the more red is the more unusual positive warm values, the more blue or the more unusual negative values. If I zoom out a little bit, actually, for over North America, what you can see is we have this dipole pattern. We have a British Columbia-centered ridge and a trough in the east, so it's cool in the eastern U.S. right now, finally some heat relief. But record-breaking warmth, even record-shattering warmth right now up in the Pacific Northwest and Canada. In fact, the latest August, the warmest and latest August temperatures ever observed, I should probably rephrase that, the latest 90 and 95 degree Fahrenheit days ever observed occurred over the past couple of days in parts of British Columbia, and some of the warmest values for this late date occurred as well during this heat event. So despite recent rain in British Columbia, fire season is once again popping back up in this part of the region with record-breaking late season and August warmth. Obviously right now it's much more pronounced across Western Canada than it is in California. California's heat was a few days ago and it wasn't as extreme, although it was notable. There still were some daily record highs, but this has been a far more remarkable heat wave for Portland, Seattle, British Columbia, and even parts of Alberta and Yukon Territory as well. So this is a northern-centered ridge, and this is today. But if I move forward in time, what are you going to see? Well, we're going to see some low pressure over the northeastern Pacific, and for a couple of days, folks thought, oh, maybe this will bring in some early rain to California. Instead, though, what looks like is probably going to happen is these are going to move into the Pacific Northwest, potentially bring a thunderstorm outbreak to Washington and British Columbia. Not great news from a wildfire perspective. Could bring some rain, but a whole lot of lightning. And that likely won't extend farther south than about the Oregon-Washington border. So this is not going to bring rain to California. We see that low pressure system well west of the state, kind of just sitting there, not really making any progress. And what we actually see is this ridging redeveloping along the west coast. So this ridge axis extending from the subtropical ocean southwest of California up into British Columbia, rebuilding as we get into 7-8 days from now. Not an extreme heat wave in California, but it's going to be returned to triple-digit temperatures in the Central Valley, warmer than average, not extreme. A little more extreme, again, up in the Pacific Northwest in British Columbia. So this could be another major heat wave up there following a lightning event. We'll see how that goes from a wildfire perspective. And what we see is just general blobby, for lack of a better term, subtropical ridging subsuming a lot of California and the West. And I'll zoom in a little bit. Again, this is going toward going into mid-September. Not a super extreme ridge signal, but once again, just general above average ridginess, atmospheric heights, and notably lack of a trough. We've seen that persistent trough a lot of the summer along the California coast. It's kept things kind of cool. Not really seeing that so much. In fact, a little bit of the opposite. We're seeing some anomalous ridging over California as we head into September. So what does this look like in terms of temperatures? Here's where we are now. It still is today warmer than average across the northern Sacramento Valley, San Joaquin Valley, but not really so much anymore in Southern California or along the coast. Still really hot up in the Pacific Northwest and British Columbia, as I mentioned. Next couple of days will be a nice little cool down in some spots in the west, but not really seeing much cooling across the interior of California. In fact, actually seeing a warm up by next week again in coastal Southern California and the San Joaquin Valley and the northern Sacramento Valley, the mountains in northeastern California. So essentially, think of where all the significant fire activity is occurring. It's in this part of the country right now, and that is exactly where it's going to really warm up once again as we head into September. And again, not an extreme heat signal for California, but just a persistently warmer than average signal across most of California, including the coastal zone in Southern California, as well as inland areas essentially everywhere else and across a lot of the west. Also notice how the Pacific Ocean west of California is really trending a lot warmer. And I will talk about that a little bit more. The other thing I wanted to point out, and I'm going to use not the ensemble for this, but just a single model representation, is that there is a tropical storm southwest of California. And later this week, it may send some moisture towards Southern California. And let me actually put up let's do this. So as you can see, some very moist air from this tropical storm. This is on Thursday, later this week, potentially not so far from Southern California. And watch what happens with this moisture. It does try and come closer to Southern California, but it doesn't really make too much progress. So maybe enough to bring some increased humidity to the Central and Southern California immediate coastline. In the European model anyway, it doesn't really kind of make it much inroads into the state. If we look at the ensemble, we kind of get a similar picture. We kind of see it close but no cigar, making a little bit of a close pass at Southern California, but not quite making it in. If we look at the American model ensemble, pretty much a similar picture. Maybe a slightly closer pass, but not really having a big effect. Now, some folks have been pointing out to some of the high-resolution refresh model, if you if you sort of use this regional scale model, step it forward in time to later this week, it suggests that some light rain might actually make it into San Diego County. There's a slight chance this could occur, but this is not really the best model to look at a hurricane track or a tropical storm track. This model doesn't exist. Its domain only extends to about here, And so right now, the storm is down here. It's outside of the model domain. So I wouldn't necessarily rely on it for something like this. If we look at some of the other high-resolution models, they also suggest this tropical storm getting somewhat close to Southern California, at least it's remnant moisture, but it really kind of peters out offshore, and honestly, not a lot happens. If we look at the ensemble version of this, here's what the European ensemble, here's for a point at San Diego. Essentially, this is a time series plot. These are each individual member of the model ensemble moving forward in time. Don't worry too much about the details, but the point is, there are a handful of model members that bring some light precipitation to San Diego, so far Southern California later this week. 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 50. So about 9 out of 50. So fairly similar to 1 in 5. So about a 20% chance of precipitation in San Diego County greater than a trace from this tropical storm. So that's pretty low, and notably not a single member of the European ensemble brings a significant, well, I guess 0.4, 0.5 inches would be significant, but there's only 1, 2, so 2 out of 50, pretty negligible chance of that happening in San Diego, though not zero. If we go north just to Los Angeles, you can see there's essentially zero chance of precipitation as far north as LA. Maybe not precisely zero, so one model member out of 51 brings more than a trace of precipitation to LA from these tropical remnants, so something like a 2 to 5% chance. So not zero, not particularly likely event. So okay, so let me bring up, I've been in the corner of the screen for a while now. Let me bring that back up and take a look at some of the questions that might be coming in. All right, here. Hello, folks. There's a question from Mark. In describing some large temperature fluctuations in association with the current heat wave, the Weather Service in San Diego used the term heat burst. Can you explain the dynamics of this phenomenon? So essentially, a heat burst, and this was a couple days ago, by the way, when this actually occurred, but a heat burst is essentially an event where rapid downward movement of air in the atmosphere produces a rapid warming of that air and a sudden increase in the temperature at the surface. This is very analogous. Well, essentially, this would be known as a dry adiabatic process from a meteorological perspective. But the idea is you have unsaturated air that is forced to descend. This is akin to pressurizing the air in a bicycle pump. So you push the pump down, you compress the air inside, it heats up. The reason why it's analogous is that when you have air that falls rapidly to the surface, well, if it's going from a high altitude to a low altitude, the ambient barometric pressure, the ambient air pressure is increasing as you go closer to the surface. So as that air descends, the pressure is increasing. PV equals nRT from your physics days, if you remember them, or your engineering days, if you're an engineer. Essentially, you compress that air as you do in a bicycle pump. All else equal, you warm that air. So, but why does that happen in this context? Well, a heat burst is usually something that comes from a thunderstorm, believe it or not, a decaying thunderstorm. So a strengthening thunderstorm has upward vertical movement into the cumulus tower like that. You have upward, you have cooling of air as it rises rapidly, you have condensation, it creates that nice anvil top, precipitation and lightning, and the rain falls down, yada, yada, yada. So it's the upward vertical movement that causes the thunderstorm. But if a thunderstorm decays suddenly under the right conditions, that air actually is going to fall back to the surface. Now, in an ordinary circumstance, it does so gradually that it doesn't make it all the way down. It's not a particularly dramatic effect. But if the air is really dry, sometimes what happens is so much water evaporates out of the cloud that the cloud just almost disappears instantaneously. And that air that was rising through a moist environment is actually descending through a dry environment, which means that it actually is kind of unstable in the downward direction. And so rather than slowing down as that air descends, it actually accelerates. So you're warming, you're compressing, and you're accelerating. So sometimes you can get severe wind gusts, damaging wind gusts when this happens. But the other thing that happens is if that air reaches the surface, it can be really hot. And we actually saw some places in Southern California that after sunset had temperatures that rose back into the 90s, really genuinely hot, up to 100 degrees because of these heat bursts. There was a heat burst that occurred, by the way, during the major August 2020, the catastrophic dry lightning event in Northern California. It was measured at Travis Air Force Base, I think in Fairfield, and it brought 6 a.m. temperatures up to over 100 degrees by this same process. Now, that was a really extreme event, but there are examples from the Great Plains and some other parts of the world where thunderstorms and therefore heat bursts are a lot more common, with heat bursts that bring temperatures up to 110, 115 degrees, even in the middle of the night. So extremely hot temperatures at the surface, rivaling some of the hottest temperatures that those same places have ever experienced during the daytime. There's even some anecdotes from the 1800s of heat bursts in the Corn Belt region that created popcorn on the stalk. I'm pretty skeptical that that's physically possible. There's been some interesting investigations, but the point is you do actually get really extreme bursts of heat sometimes from decaying thunderstorms like that. So it's an interesting question. So, then this reminds me, there's a couple of questions about the monsoon or monsoons. A little bit of important lingo and description of what is a monsoon. A monsoon is not a downpour of rain. It is not an individual storm. A monsoon is a seasonal reversal of a wind pattern. That is the definition of the monsoon. Now, there are multiple monsoons on Earth, but there aren't, thousands of them like there might be for individual thunderstorms. There's maybe half a dozen or so monsoons on Earth, and they aren't events that occurred briefly. They are large-scale, sometimes continental-scale reversal of seasonal wind patterns. So the most famous one probably is the South Asian monsoon that affects India and Pakistan, South Asia, brings precipitation, much needed precipitation, at the end of the hot season. So the hot season in a lot of India, in Delhi, the interior of India, for example, is actually earlier in the astronomical calendar year. So it's in May or in June rather than July and August. Why is that? Well, in July and August, unless there's a failure of the monsoon, heavy thunderstorm rains have arrived because there is that seasonal reversal of the wind as the continent heats up. This is an oversimplification. It turns out that the monsoon dynamics are even more complicated than scientists believed a decade ago. But as the continent heats up, that surface heating produces a surface low pressure system on the Indian subcontinent, because you have water on three sides, remember. The air rushes inward from all sides, bringing that moist marine air. It's still hot, but it's much moister, and it produces that rainfall. In the American Southwest, there is what's known as the North American monsoon. Now, you might not think of Arizona as having similar climate dynamic to India, but if you actually look at the geography, the similar pieces are A, proximity to a really warm, moist bodies of water. The closest part of Arizona is actually only about 100 miles away from the Gulf of California, which is bathtub warm, remember. And some of that moisture also comes from the Gulf of, let's call it Mexico. Not as close to Arizona, but because of wind patterns, you can still get big Gulf moisture that moves westward toward the desert Southwest. So ironically, the air in Arizona in July usually has far more moisture in it than the air in San Diego or San Francisco. And that might seem odd if you think about how much fog there is in San Francisco, but remember, when we talk about the absolute quantity of moisture, we're not talking about relative humidity. If you're in San Francisco in the fog, the relative humidity might well be 100% or close to it. And the humidity on a really humid day in Phoenix might only be 30 or 40%. But think about the temperature in San Francisco when the relative humidity is 100% in the fog. 55, maybe 60 degrees if you're lucky. In Phoenix, that 30 or 40% relative humidity it might be 115 degrees. And so, because we know that expanding atmospheric sponge, I've talked about before, the atmosphere's capacity to hold water vapor increases exponentially with a rise in temperature. That 30 or 40% relative humidity air in Phoenix has way more water vapor in it than that 100% relative humidity air at 55 degrees in San Francisco. And so, because there is so much more moisture in the air to the east of California in summer, so the desert has way more moisture in the air than does the California coast. I know this is a little bit weird. When the winds reverse, when the interior of the west heats up and produces that surface low pressure system, draws in some of that moisture, when there is an upper level high pressure system that can move that moisture westward to California, and I know this is getting complicated because we're talking about a high pressure at upper levels and a low pressure at the surface, and don't worry too much about it, but the point is the desert actually, by virtue of how hot it gets, draws moisture in from these warm bodies of water in the summer. That's the monsoon. It's a seasonal reversal of the winds. They're no longer from west to east, which is ironically, when the winds come from the west, from the Pacific Ocean, it's a dry air mass in Arizona. When the winds come from the south or the east, from the even hotter regions over the continent, it's usually a moister air mass. I know it sounds weird, but that is the physical reality. When the winds come from the east, when the wind blows from Arizona in the summer, California gets thunderstorms. When the wind blows from the west, it's cool and foggy at the coast. This week, we got all these mountain thunderstorms and thunderstorms in some other places too, because we had this prolonged period, this reversal of the winds from east to west, bringing all of that moist desert air into California. So monsoon, simply, is a reversal in the seasonal wind pattern. The North American monsoon is the one I'm talking about in a California and U.S. context, but there is the South Asian monsoon. There are monsoons of different flavors and varieties in Africa, in Australia, and in South America. There's also monsoon-like patterns in Oceania, the big subcontinents, the big islands and tropical islands in the Pacific. Really anywhere where there's a semi-recurring seasonal reversal of winds that brings a big humidity shift. Now, a lot of folks refer to individual storms or downpours, thunderstorms, as monsoons. It's, to be clear, I'm usually a big advocate for using colloquial language to describe things, but I actually think it's really important for folks and for journalists in particular to understand that it is factually inaccurate to describe individual downpours as monsoons, because the whole point of a monsoon is that it is a subcontinental or even continental scale reversal in the typical direction of the winds that can bring storms and rain and thunderstorms and a humidity shift. But isn't that unto itself? What the monsoon is fundamentally is a seasonal reversal of a typical wind pattern. And I know a lot of folks, especially newcomers to the American West, are surprised that there is a monsoon in the West or North America, but I assure you there is, and if you've been under any of the downpours this week or experienced the humidity, including along the Southern California coast where ocean temperatures are now well up into the 70s, it's getting pretty muggy out there, you probably have experienced it more tangibly. Question from Don, any insights on the Haboob dust storm? The Haboob is an Arabic word from which this process is named. There's a few different definitions as to what the origin of that word is. Maybe there's some native Arabic speakers who know more specifically, but essentially the various definitions I've seen is that essentially it means a strong, dry wind in Arabic. In a meteorological context, it is specifically referring to a specific type of wind-driven dust storm from the outflow boundary of a thunderstorm or some other surface-based density current. So it's a really sudden, acute dust storm associated with strong winds, and you can see it coming. It's like a wall of dust, and we saw that in Arizona. There's all these amazing images of this wall, this curved wall of dust. It's quite like if you were to drive into it, it would be sunlight, daytime, middle of the day on one side of it, and almost midnight dark 10 seconds later. That's how dramatic it is. And this was one of the better ones I've seen in terms of the visual imagery we saw coming out of Arizona. So again, they commonly occur in places in deserts that experience summer thunderstorms with downbursting winds. That's exactly what happened in Arizona yesterday. And there's some questions about Burning Man. They got the dust storms, they got the flooding, they got the dust storms. Folks are always surprised that you go to the desert and it rains, but Burning Man is in the desert during the rainy season. The rainy season in this part of the country is August. It is the summer. It is during, literally, the monsoon. It may not feel like it all the time because the monsoon is more transient. It is not as consistent as it is, say, in South Asia. But it is there, and it is not that surprising that the desert sees heavy thunderstorms in August, or dust storms, or both, as the case was this week. So another pretty miserable weather year on the playa, it seems. It's been a string of bad ones last few years, as I've heard, for different reasons. There's a lot of good questions. I won't get to all of them today, but I do want to get through as many as possible. And I also have that brief weather service update I want to offer too, before we get too far past the hour. You'll probably get about 10 bonus minutes today, I'm thinking. Yeah, looking at watch duty, there have been a ton of wildfire ignitions. We're probably well over 100 wildfire ignitions just in California from lightning over the past 3 days. And the good news is most of them have kind of skunked around and not done a lot, or have probably produced a very localized benefit, adding to the mosaic of fire intensity and frequency across the landscape, and not done much more than that. But a few of them have gone big. A few of them are in the thousands of acres. There's a couple in the hundreds of acres. And I would expect that as things dry out and as the thunderstorms move away in the coming days, that there will be at least a handful of these that go on to cause some problems. That would be my expectation, partly because we're also seeing them simultaneously in Oregon, Washington, Idaho, Montana, and other states. So there's a lot of activity right now. Comment from Cool Bam. Supposedly there was a mini land spout, so a weak tornado essentially, that occurred in the storms that passed through the Imperial County desert. Wouldn't be too surprised. There have been some strong storms out there, and a land spout doesn't really require the classic severe convective weather vertical setup. You don't really need that vertical wind shear, so often there's boundaries out there. Sometimes if you're really lucky and there's a dust devil out there in the desert underneath the cumulus cloud, it can essentially attach itself, for lack of a better term, that riding the vorticity boundary and create what is, in effect, an actual tornado from a dust devil if the thunderstorm attaches to it. So perhaps that's what happened. Haven't seen any images of that, but those are usually pretty photogenic and kind of cool because they're usually pretty weak. They don't cause a lot of damage, but they can look pretty interesting. All right, here, let's see, getting close to the end of the comments here. Nice question from Benjamin. Why does monsoon moisture rarely ever make it into LA City? When it does, it's usually just a few sprinkles. That's the most common outcome. There have been a couple of big thunderstorm downpours in recent years, and also sometimes the moisture makes it in the form of humidity, even though the rain doesn't, so it feels muggy and uncomfortable. The main reason is that you often need some kicker to generate upward vertical motion and thunderstorms in the air. In the deserts, the air is so moist and warm and unstable that it can kind of just happen spontaneously. In LA, though, it's usually not hot enough, and you have the moderating influence, the stable marine air west of the mountains that is actively suppressing the upward vertical motion, so it's actually acting downward. The mountains in LA County in Southern California, they can provide enough of a localized heat source to kick off those storms, but they die, usually, as soon as they move off the mountains. The exception would be, and this is why we saw thunderstorms in the Central Valley last night, for example, is if there is some disturbance in the middle or upper atmosphere that makes it unstable, that serves as a focal point for giving a little bit of an upward vertical motion kick. If you already have that moisture and instability, all you need is a little kick. Sometimes that's still too much to ask, but apparently last night there was that little kick that got those initial updrafts moving, and then once they were moving, there was enough. Even though it was over the Central Valley, there's no isolated heat source, there's no front or anything like that. It was enough to kick off some significant convective development. But that's also why you tend not to see it in the coastal parts of California. The marine influence is stabilizing. It just actively extinguishes most convective events, and usually the air just isn't unstable enough to begin with without some external triggering mechanism. All right. Well, I'm glad the birds are audible in the background of this and nothing else. That's probably one of the better background noises you could potentially encounter on a live stream like this. So the last thing I wanted to talk about a little bit, and I did well. Actually, let me double check that there's nothing crazy going on with the most recent storms. There are some flash flood warnings up on the storms up north and east of Weaverville, but that's not too surprising. As well as a few flash flood warnings down the deserts. We talked about those as well. So the last thing I wanted to talk about briefly in this conversation, now I'm noticing that my lighting has kind of washed me out as the lighting here has shifted into the evening. Well, in any case, what I really wanted to close with is an update regarding the Weather Service. And we've talked a lot about how Elon Musk's Doge cuts sort of, in a very untargeted and haphazard way, really decimated a lot of these local offices, including multiple offices in California. So up through present, so far as I understand, there are still Weather Service offices in California that are not fully staffed at night. That has not yet been resolved. But there was a recent policy reversal of sorts where there's an intensive effort to hire a few dozen, I should say rehire, a few dozen meteorologists and other roles in the Weather Service at some of these offices that were so decimated earlier this year. Keep in mind that there were hundreds of Weather Service and NOAA positions lost, and the rehiring is only in the order of dozens, so it does help, but we're still a net loss. The other thing I wanted to point out, and this was something that was I was made aware of by John Morales, a meteorologist well known in Florida, if you ever lived in South Florida, that the hiring requirements for probably other federal roles as well, but this is specifically drawn from the application process for the National Weather Service meteorologist. So this is essentially a requirement for anybody who's going to fill new roles at the Weather Service in the Bay Area or Sacramento or anywhere else in the country, which is something that we've never seen before. I've never seen it. He's never seen it. Folks who worked in the Weather Service have never seen it. There was some discussion about whether there would be a political partisan litmus test for who would be allowed to be hired. The federal government said that it had backed away from this, but I'm going to read verbatim from a snapshot from the application process, and I'll let you decide what you think. And if you want the source for this, by the way, John has posted screenshots of this publicly on Twitter or X. Is that one of the written essentially essays that you have to provide to be hired now within the Weather Service is, first of all, how you would, quote, use your skills and experience to improve government efficiency and effectiveness. That in itself, I suppose, is not an entirely unreasonable question to ask in the hiring process. I think everybody values actual efficiency and actual effectiveness, though I think it's only reasonable to read between the lines, given that DOGE, the so-called Department of Government Efficiency, is the one mandating these questions. What is actually being asked here is a little bit ambiguous, but I think the far more problematic one that is on its face, something that we just haven't seen before is the following. And this is the full question, verbatim. Quote, how would you help advance the president's executive orders and policy priorities in this role? Identify one or two relevant executive orders or policy initiatives that are significant to you and explain how you would help implement them if hired. Again, this is pulled verbatim from the application to be a National Weather Service meteorologist in the tier of roles that are trying to be desperately refilled after the purge earlier this year. I don't know if this is extending essentially to all civil service roles in the federal government, but based on what I'm hearing, similar political litmus tests, partisan political litmus tests, if not the exact same one, is being applied to anybody applying for any civil service role. Again, these are not political appointments. These are ostensibly civil service roles that have no connection of any kind to partisan political politics. That's actually been a big piece of what it means to be in the American civil service for many decades. This is going to affect the hiring process, and I have spoken with people who might have been interested in a federal meteorology role who are disgusted by this and are inclined not to apply. So I don't know whether this will affect the ability to fill these roles. I don't know the degree to which people will just roll their eyes and figure out an answer that will get them past this apparent political litmus test. But it is concerning that this is being asked even of someone like somebody who might be responsible for issuing a tornado warning for your neighborhood, or a flash flood watch, or a wind advisory, or a fire weather warning. It just doesn't make sense. These aren't partisan political roles. They never have been. They shouldn't be now, and I hope they won't be, despite the new hiring requirements. But I did want to offer that this is not back to usual, both in terms of the fact that many of the so first of all, very few, if any, of the people who were fired are personally going to be rehired, realistically. And second of all, there's a political litmus test involved. And third of all, the number of roles that are currently open is still far less than the number of people who were let go. And the final piece I wanted to add on this most recent federal update piece is that there was some news yesterday that the federal government and Russell Vogt in particular through the OMB is moving via the executive branch and OMB to preemptively unfund various parts of NOAA, particularly related to climate and climate change and weather research, even if Congress fully appropriates the funds for the coming fiscal year. So there are some funds from the current fiscal year which are probably not going to be spent at all, even though they've been allocated. They've been mandated by Congress. The funds exist, but they may be returned to the Treasury because they do not align with the current executive branch priorities. And there is a now written explicit expectation that same procedure or similar one may be used next year with the new fiscal year, even if Congress fully funds the Weather Service and NOAA research and NASA research and all of this. These programs and facilities may still be shut down simply because the federal government decides, using mechanisms that may or may not be legal or constitutional. I'll leave that as a discussion as a conversation for the legal and constitutional experts out there. But there may be a pretty big gap between the funds that Congress appropriates for weather and climate and what actually is used or allowed to be used by the federal government. And there is already it was previously implicit. I think the news this week is that this is now explicit, that this will be implemented as a policy to preemptively defund programs, policies, and people who are not in partisan political alignment with the current administration, specifically in weather and climate. Even if Congress fully appropriates those funds, as they may well do, based on the way the current budget is looking. So I just wanted to add that as the most recent development. As always, thanks for joining. It's been an active day. Next update will probably be focused somewhere along the lines of wildfire, just based on what I'm seeing out there right now. So not seeing any really extreme fire weather days, but we got a lot of ignitions from lightning. We'll see what they do. We'll see how warm and dry it gets in the coming weeks across the West Coast. Keep an eye on that tropical moisture in Southern California, but right now it's not looking like a very big deal, except maybe a bit of light precipitation down in San Diego if we're lucky. Aside from that, could see some very nice days along the coast as those near-shore ocean temperatures warm up and as we get into the coastal summer, which begins in September most years anyway. Thanks for joining. See you next time.